This is an overview video of College Trigonometry version 3 by Stitz and Ziegler. 10.6.1 Inverses of secant and cosecant. Trigonometry friendly approach. When picking a one-to-one section from secant, there is an infinite number of possible values. This section between 0 and pi gives a very nice arc secant when you're working in trigonometry. This is the correct range for the way your class is being taught. There is another range that will be discussed briefly at the end of this video. Arc cosecant, its one-to-one section that's used, is between negative pi halves and pi halves, not including 0. That's why you have this slightly different version than the arc sine, for example. That section gives you a nice arc cosecant graph that is a function. If we take a look at the properties of arc secant and arc cosecant using the trigonometry friendly ranges, we have the domain is everywhere from negative infinity to negative 1 and then from 1 to infinity. This is the same as the range of secant. The range is just this section, so it's essentially quadrant 1, not including pi halves, and quadrant 2, not including pi halves. Pi halves is where cosine equals 0, so secant would be undefined. Arc secant can be written as in terms of arc cosine, and you flip the inside, the value inside when you do that. Secant and arc secant essentially cancel, assuming you're in the correct domain for arc secant, and arc secant and secant cancel, assuming that you're in the correct range for arc secant. And arc cosecant, similar information. Additionally, you get arc cosecant as odd. Now, the reason why these are trigonometry friendly is you do have, for example, arc cosecant. Cosecant's the reciprocal of sine, and this is sharing very much the same type of information as the arc sine function. Secant is the reciprocal of cosine, and this information is being shared very similarly with the arc cosine function. If we wanted to look at an example or two, for A, we have arc secant of 2. We can change this to arc cosine, and then the inside flips. Now arc cosine lives in these two quadrants, as does arc secant with these trig-friendly ranges. And where's cosine positive 1/2? It's right here. That would be pi thirds. Arc cosecant of negative 2 can be changed to arc sine, and then the inside value do the reciprocal. Arc sine and arc cosecant live in these two quadrants. Arc sine is negative 1/2 right here. That would be negative pi sixths. Arc secant of 5 pi fourths, secant and arc secant essentially cancel, assuming this is in the correct range. However, this one is not. 5 pi fourths is right here. That is 5 pi fourths. Arc secant lives here. All students take calculus. So 5 pi fourths secant is negative. Only tangent and its reciprocal cotangent are positive. This is the other location where secant is negative. So these two quadrants share secant as negative. This one, secant lives. So we essentially have to convert this angle to an angle where arc secant lives and is the same sine. That would give us 3 pi fourths. You could also work out secant of 5 pi fourths and get negative square root of 2 and then work out what is arc secant of negative square root of 2 and find that it's 3 pi fourths. That would work as well. Finally, cotangent of arc cosecant of negative 3. Since negative 3 is not a value we're used to from the unit circle, we're going to draw a triangle. All arc functions can be thought of as an angle. Now, where does arc cosecant live? It lives in these two quadrants, and it's negative down here. So I'm going to draw a triangle down here with theta. Arc cosecant is the reciprocal of arc sine, so it would be sine would be negative 1/3. Negative 1/3. That is cosecant is negative 3. The Pythagorean theorem would give us 9 minus 1 is 8, square root of 8, which we can reduce. And this is to the right, so that one's positive. This is down, that one's negative. And the hypotenuse is out, so it's always positive. Now do cotangent of that. Cotangent is adjacent over opposite. So we would get square root of 8 over negative 1, which can be reduced to negative 2 square root of 2. And that would be the answer to part D. Rewriting in the following is algebraic expressions of x. Algebraic means no trig functions, just algebra. So if we were to take a look at, doesn't matter, let's look at B, arc cosecant, we would set up a triangle. So theta is arc cosecant. And 4x, sine would be 1 over 4x, so 1 over 4x. That would be sine, and so arc cosecant. So cosecant would be 4x over 1. We then would do Pythagorean theorem to get the remaining angle, the remaining side, and then we then proceed to do cosine of theta, adjacent over hypotenuse. And that would be an algebraic expression, no trig anywhere in there, for cosine of arc cosecant of 4x. The inverses of secant and cosecant, if we're using a calculus-friendly approach, you might see these ranges in your calculus book. We're not going to do homework on this. Just notice that this is quadrant 1 and quadrant 3 in both cases. Slightly different. They're just taking a different section of the secant and the cosecant to make a different part of an inverse function, the different section that's 1 to 1. So there are two choices, and this book has homework in both. Make sure you're doing the one that is the trigonometry friendly.